Hello everyone, welcome back to the channel. I hope you all are doing great. So we started with our chapter that was heterocyclic compounds. In that we made the classification of the heterocyclic compounds in the saturated heterocyclic compounds and the aromatic heterocyclic compounds. The saturated heterocyclic compounds we have already covered. We started with the aromatic heterocyclic compounds. In that the first compound that we discussed was the pyrrole in the last class. So now we are moving on to our next aromatic heterocyclic compound, which is your furan. Okay, so before starting the class, if you are coming to the channel for the first time, make sure you subscribe to the channel and do press the like button also for the video if you understand the concepts, and do share it with your friends as well. Okay, so now let us begin with the next aromatic heterocyclic compound, which is our furan. So we are gonna discuss today is about the furan. So what is basically furan? A five-membered ring containing the oxygen like this. So it is your aromatic compound having the 6 pi electrons, and comparing its aromaticity with the other aromatic heterocyclic compounds, it is your least aromatic in the nature. So with this order we have already seen that benzene is the most aromatic, followed by your pyridine. Then we have is your thiophene, and then we had was the pyrrole, which was five-membered ring containing the nitrogen. Thiophene contains the sulfur like this, and here nitrogen atom is present, and the least one was your furan, which is your this species. So today we are gonna focus upon the least aromatic heterocyclic compound, which is our furan. Okay, so just like the pyrrole only, the this ring pyrrole ring is gonna this furan ring is also gonna give the reactions. So just like the pyrrole ring, it was giving the electrophilic substitution reactions. Electrophilic substitution reactions. Here also we are gonna see is the electrophilic substitution reactions only, and the attack of the positions where the attack is gonna occur. So here you have this oxygen, and this like this is present. Oxygen is having the 2 lone pair of the electrons. One of the lone pair of electrons is involved in the conjugation, providing the aromaticity to the ring, and the other is in the perpendicular py orbital it is present, that is not involved in the conjugation. But this lone pair is present on the oxygen center, which is your highly electronegative element. So if the electrophile species is coming for the attack, this lone pair of the electrons that is present in the py orbital of this oxygen atom is not gonna go for the attack, because it is present on the highly electronegative element. So this electrophilic substitution is not gonna occur at this position. So which means that we are left only with this four of the carbon sites, where this hydrogen atoms that are present can be substituted by your electrophiles, right? So here also you are gonna see that there is a presence of the plane of the symmetry, right? Like the case in the pyrrole it was there. So this was your carbon number 2, 3, 4 and the 5. 2 and the 5 are equivalent, 2 and the 5 are equivalent, and similarly carbon number 3 and the carbon number 4, they both are equivalent for the attack of the electrophile, right? Similar to the pyrrole, the attack will be at the positions 2 second carbon, the attack will be the most favorable, followed by the fifth carbon center, and the least will be your third carbon center. That attack is gonna be there. So this is gonna be the order for the electrophile to attack over the species. Okay, so now we are gonna see the electrophilic reactions over the furan. Just like the pyrrole only the reactions are there, but we can have a look over to that now. So here you are having is your furan. On this they have passed is this reagent, that is your nitric acid with in the presence of the sulfuric acid. So this particular reagent we make use to carry out the nitration. So this is used to carry out the nitration, Among the nitric acid and the sulfuric acid, our sulfuric acid is more acidic in nature. So here H positive will be provided from your H2SO4 to your nitric acid, which is my this species. Here nitrogen double bond oxygen, here this like this bond is present, and the OH. So the H positive is gonna protonate this oxygen center, giving us the formation of the N double bond O, this species. Here the OH2 with the positive side. So this water is gonna leave from the medium, leading to the formation of the electrophile, which is our NO2 positive. So now this electrophile is gonna go for the attack over our furan ring. Now the attack feasible is at the second position, followed by the fifth and the third position. So this is basically number one, number two center, third, fourth, and the fifth. So the electrophile is gonna attack at this position. So this electron density is shifted. So we are gonna get here, is this species getting being formed. Here the positive charge will be present, and the electrophilic attack at the second position is occurring. So this now electron density can be donated. So we are gonna get here, is this kind of the species. Here the oxygen is gonna have the positive charge, and here is your NO2. So this is the another resonating structure that is possible. Now further, to regain back the aromaticity of this ring, this H positive is gonna lose, this electron density will be shifted so that the positive charge on the oxygen can be neutralized. So ultimately we are getting is the substitution at the second position. So this is gonna be your final product, right? So the main thing is, in the nitration at the second position we have is the nitro group getting being attached, right? Now moving on to our next question that we have is this species. So this was number one, and this is the number two question. So again furan ring is there, and here they have given us acetic anhydride, which is my CH3 C double bond O oxygen with the C double bond O and the CH3 species. Now they have given along with that is your Lewis acid. So the reaction is basically your Friedel Craft reaction, you can call it. So what is going to happen with the in the presence of the Lewis acid, one of the carbonyls electrophilicity will be increased. So suppose this chelation is there with this Lewis acid is forming the chelation with this oxygen center. So what is going to happen now, this electron density it has shifted to this side now. So this is gonna go for the attack at this position. This electron density will be going to the oxygen, coming back, and this group is gonna leave from the medium, forming the species which will be your oxygen. Right here the positive charge is there, and here the group that is attached will be your acetic C double bond O CH3 species. Further you can at that resonating structure you can draw it out, loss of the H positive in the final step, regaining back the aromaticity. So we are gonna get here is this formation. So here ultimately just the substitution at the second position with the COCH3 species is gonna be there, and this is gonna be your final product, right? Now let us move on to our next question, which is your this. Now here they have given that furan is treated with the reagent which is CHCl3 with the KOH. So it is looking like your Riemann Tiemann reaction. So it is looking like my Riemer Tiemann reaction, in which my intermediate formed is the carbene. So how is that gonna be formed? Here we have now CHCl3, and along with that they have passed is the KOH. So now KOH will come, abstract the proton from here, and the negative charge will be formed on this carbon center. So now we have here 33Cl with the negative charge, right? And along with that we had the loss was of the water. So here the from this carbon center, one of the Cl group will be leaving, leading to the formation of your carbene, which is your CCl2 carbene, right? So after the alpha elimination, this carbene has been formed. Why is it called the alpha elimination? From the same carbon center, two of the groups are leaving. One is the hydrogen and one is the Cl group. So this type of the reaction is called as your alpha elimination. So this CCl2 carbene will be formed. Now this CCl2 carbene will be going for the reaction with your furan ring, right? So how is the reaction gonna proceed? Let's do it on this slide. So now here the furan ring that we are having. Let me draw this again. This is not looking nice. So here we will be having this ring. Okay, and the CCl2 carbene is there. Now carbene can show the pi insertion. So this pi bonds in this pi bond, this CCl2 will get inserted. So here this species will be formed, the Cl and the Cl group is present. Alright, now three-membered ring is present. We are to release the strain from it. So the oxygen having the electron density will be shifted like this, and either your bond A can break, this is bond number A, or your bond B can break. So if the bond A is breaking, so in that case we are gonna have is this species. So through the path A, if we consider, here the oxygen, from the oxygen electron density moved, here oxygen has donated the electron density, so positive charge is coming and the bond is getting being formed at this position, and at this center we are having is the carbon with the negative charge having the 2 chlorine atoms are present, right? So now further what is going to happen, this H that is present from this center will be abstracted by this carbon which is having the negative charge, so that the aromaticity of the furan ring can be regained. So what is going to happen here, this CH bonds electron density will be shifted to this side, this is gonna shift to this side, and the positive charge on the oxygen will be neutralized, giving us this species now. Okay, so now we are having this species getting being formed. Here we have CH with the Cl2, right? Now this species that is formed, which is C H and the 2 chlorine atoms. Now in the reaction medium we had was the KOH. So this KOH is gonna come for the attack at this carbon center, and one of the Cl group will be leaving from here, giving us the formation of this species. Now we have here is CH with the Cl, and we have is OH species is there. Now again we have is the basic medium. This OH is gonna abstract the proton from here. The O negative species will be formed whose electron density will be moving forward, and this Cl negative is gonna leave from the medium. So giving us the formation of the species which will be my furan. At the second position we have is the aldehyde group. So this is the product A which we can expect that is formed if the bond A is breaking, like in this particular species. Right, now let us have a look for the if the bond B is breaking, then what product we are getting in that case. So now we had was this species, after the pi insertion we got here this Cl, and the Cl species was present. Just a second. So we were having was this species having the carbon with the 2 Cl groups, right? Now this oxygen's electron density is gonna move, this will be shifted. Now this was the bond B that was present, so this electron density will be shifted to this side, and the one of the chlorine will be leaving from the medium. So we are gonna see is the expansion of the ring. So here is number 1, 2, 3, 4, here will be 5, 6, 6-membered ring we are getting, it is getting being formed. So we are getting here is this oxygen center which is number 1, the 1 and 2 bond is getting being formed. Again this is, let me label this first of all, 5 and the 6th position. At the bond is for getting being formed between the 3rd and the 4th position, and the 5th and the 6th bond is getting being formed, and at the 5th position we have the Cl group. Now in the final product oxygen is having the positive charge because it is forming 3 bonds. So right, this is gonna be your product B. So now let us have a look over to the stabilities of the product A and B and see which of the products will be being formed. So in the product A, we are getting is the aldehyde group, and here is, if the bond B is breaking, here we have got was this species. Here the positive charge is present, and at the fifth center the chlorine was present. So this species is getting being formed. So among these two, this one is your more stable because it is a neutral species is there, right? And here you are getting is a charged species getting being formed, and charged species are comparatively lesser stable, so the neutral form of the product will be the more stable, which means the final reaction, if we see, that is for this one, in this case the final product we will be having is your this one. Had there been the pyrrole case, here the nitrogen center, if it was present and the same species we were passing CHCl3 with the KOH, in that case your pyridinium chloride was your major product, because here the species formed was your neutral, and it was in fact having the more aromatic character than the 5-membered ring with the substitution of the CHO that was getting being formed. So here product form is different, whereas in the furan this species is getting being formed. So you have to remember that in the furan case the CHO substitution is there with this particular reagent, that is of the Riemann Tiemann reaction, and in the case for the pyrrole there is gonna be the ring expansion, and we are gonna get is this species getting being formed, right? So now let us move on to our next patient, which is your this one. Here they have passed now is the POCl3 with the DMF. Now in the pyrrole also we have seen this reaction. What was happening? The at the ortho position, that was at the second position, we were having is the substitution of the CHOO group. Here also the same reaction is gonna occur, and we are gonna get here is the formation of this species getting being formed. This is gonna be your CHO. So how is the reaction proceeding here? We had was the PO with the 3,3 Cl centers, right? And then we had was the DMF, which was my N dimethyl formamide. Now this nitrogen's electron density was moving. This electron density was shifted to the oxygen, and this was forming the bond with the this phosphorus center. This electron density will be moving, coming back, and one of the Cl will be leaving. The driving force behind this is the bond formed between your phosphorus and oxygen, that is very strong because of the presence of the back bonding in it. So we are gonna get here is P double bond O with the 2,2 Cl. Now oxygen has formed the bond which was attached to the carbon center having the hydrogen, and the nitrogen with the positive charge it will be present, right? Now further what is going to happen is, what is going to happen next, the Cl group that has left from the medium is gonna come for the attack, and this group is gonna leave from the medium. Again the driving force is the bond formed between the phosphorus and the oxygen. So we are gonna get is the species which is my CHCl with the double bond NMe2. Again the still the positive charge is present. Now the furan ring is gonna come for the attack. This electron density is shifted, this will be attacking at this center, and the charge over it will be neutralized. So we are gonna get here is this species. Here the positive charge will be present, CH with the Cl, and the NMe2 will be present. Again nitrogen will be donating its electron density, and this Cl is gonna leave from the medium. So we are gonna get here is, here the positive charge CH with the double bond NMe2 is present, and along with that here the loss of the H positive with the aromaticity of the ring will be regained. Okay, so we are gonna get here is this ring that is aromatic, and here this species is formed, and further the hydrolysis of this will give you the species. Hydrolysis of this group is gonna cleave, and we are gonna get a CHO getting being formed. So in the final product we are gonna get is the furan ring with the CHO substitution. So this was the product that I already wrote. So the whole mechanism is going like this. Okay. So moving on to our next question now that we have is this one. Now here they have passed in the furan. First step they have given is the butyl lithium, and then the CO2 and the H positive is passed in this. So what is going to happen? The lone pairs present on the oxygen will be showing the chelation with this butyl lithium's lithium atom. So we are gonna get here is this species. Here the chelation is there between the lithium and the butyl negative. So from the ortho position now, this hydrogen will be abstracted by the butyl lithium. Why is that actually happening? Because here you can see that it is butyl is something, four carbon atoms chain is there, 1 2 3 4. Here this carbon is having the negative charge and lithium ion was present as a counter ion. So this carbon center is basically your sp3 center. Now after abstracting the H positive from here, we are gonna get is the negative charge getting being formed at this particular position, which is my sp2 center, having the more amount of the S character as compared to your sp3 center, right? So since more S character is there, so in the sp3 and the sp2, the percentage of the S character, if you see, it is here 25%, and here you have is your 33%. So this is more in this case, and more is the S character, more is the electronegativity, more is the percentages, more is the electronegativity, which means that after the abstraction of the H positive, this negative charge is now getting being stabilized, because negative charges are stable over your more electronegative species, right? So this thing is gonna happen in the first step where the butyl lithium is there, and the driving force is this species is having the negative charge, which is your sp2 hybridized now, right? Now further what is going to happen, this negative charge species that has been formed on this, there will be the attack of your CO2 species. This species is gonna attack, this electron density will be shifted. So we are gonna get here is oxygen with this, and the carbon double bond oxygen and the O negative will be there. Now further the acidic medium is given, so the protonation of this O negative will be occurring, and we are gonna get is this, at the second position your acid will be formed. So this is gonna be your product, which means here the final product is this one. Here the furan having at the second position your COOH group. Okay. Now moving on to our next question, that is your this one. Now here again butyl lithium is passed, and we have is B are substituted at the third position, and the lone pair of the oxygen is also present. Now in this case oxygen is not gonna show the chelation with the lithium. In fact what is going to happen is there will be metal halogen exchange reaction. We are gonna have is metal halogen exchange. First step will be your metal halogen exchange reaction, and in that what is going to happen, negative charge will be present over this center. So you can see that LiBr is leaving from the medium, and you are getting is a negative charge at this position. Right now further CO2 and the H positive, if it is passed, so this negative charge will be attacking from this particular position now, and this electron density will be shifted. The next reaction is the same only. Here the carboxylic acid will be formed. The protonation of it is done. So that means at the third position now, here the COOH is present. That means if in the furan we want the COOH group to be present at the second position, then just treat it with the butyl lithium, where this lithium ion is gonna show the chelation, and the whole process is gonna go like this. And the second position COH group we will be getting. But if we want it to be present at the third position, in that case initially you have to take is your substituted species. So first step will be the metal halogen exchange reaction. So a negative charge will be formed at the third position, and the rest reaction is gonna be the same only. So at the third position we are getting now is the acid getting being formed. So this is our final product, right? So now moving on to our next question that we have is not this one. Now here in the first step, they have treated the furan with the species, which is your CHCl3 with the KOH, and then in the next step, they have passed as your KOH. Okay, so the first reaction, which is when the furan is treated with the CHCl3 and the KOH, is like the Riemer Tiemann reaction, and we have seen its product, that was my aldehyde group at the second position was getting being formed. This product was your stable one, right? So that means in the first step, if the CHCl3 with the KOH, if we are treating, so we are gonna get is this species. At the second position, you will be having is your aldehyde. Now in the next step, they have passed is your OH negative, that is basically your KOH. So what is going to happen? This O negative will be going and attacking over this carbonyl center, and this O negative is gonna shift upside. So we are getting here is this species, right? CO negative, and here is the attack of the OH, and here we had was the hydrogen center, right? So now this species basically is your substrate for your reaction, which is known as your Cannizzaro reaction. So what is in the Cannizzaro reaction? Basically we have is the no alpha hydrogen is present. So here also in the carbonyl species that you are having, at the alpha position to it, there is no hydrogen center. So basically in the basic medium, what type of the reaction we are gonna have is now, that is your Cannizzaro reaction. Okay, now here in the Cannizzaro, what is going to happen? This O negative electron density is gonna move, and this H as a hydride ion, which is your H negative species, is gonna leave from the medium, and in the reaction we have more amount of the furan, this furan which is substituted by the CHO group will be present. So this hydride that has shifted will be going for the attack at this oxycarbonyl center, and the oxygen's electron density, alkene's electron density will be shifted to the oxygen center. So we are getting here is this species getting being formed, that was this in the first case, that is where from where the hydride has abstracted, and along with that we are getting is this species getting being formed, that is the attack over the another furan species which was substituted by the aldehyde. We are getting here is now here O negative will be present, here the hydrogen is present, and one of the hydride it has shifted. So ultimately after the workup of this, we are getting is this species, right? And one is this species. So basically in the Cannizzaro reaction also we see that the same species undergoes, one is the oxidation and other is the reduction of this. So when no alpha hydrogen is present in the basic medium, we have one is the oxidized product. So here is the oxidation of it, and here is the reduction of this. So basically you can see here we had was the aldehydic group, which is after the addition of the oxygen, oxidation is occurring, so it is getting being converted to the COH group, and the after the reduction your CHO is converting to the CH2OH. So simultaneously both of these processes they generally occur in the Cannizzaro reaction, where no alpha hydrogen is present in the medium. So first step, they formed the aldehydic group using the reagents that was of the CHCl3 and the KOH, and then the basic medium is gonna give you this particular reaction. Okay, so the main thing is we must know that the after this aldehyde formation in the basic medium, the reaction that is gonna occur is your Cannizzaro reaction, and then that the products formed is one is the oxidized product and other is your reduced form of it. Alright, now we are gonna move to the next question that we have is your this one. Okay. So now here the another name reaction you are gonna encounter in this case. So first step is your aldehyde group aldehyde will be formed in the presence of CHCl3 and the KOH. Alright. So first step will be the formation of my this species. Right. Now in the next step they have passed is the KCN. So CN negative is there, that is ionic species. Now this bond can break and is gonna attack at this species, and this electron density will be shifted to the oxygen, giving us this species. Now here carbon with the O negative, and here we will be having is the hydrogen, and here the attack of the CN it has occurred. So this species is getting being formed. So now here in the reaction medium you are gonna have more amount of this furan with the substituted aldehyde groups also. So what is going to happen now? This species C with the O negative, where the hydrogen and the CN is there. So here now what is going to happen? We are gonna have in the first step here, here now you are having is the CN group, which is your good living group. So the reaction here you are gonna have is your benzoin condensation. Here you are gonna have is benzoin condensation. So what is going to happen here is this O negative is gonna abstract this hydrogen from this particular carbon center. Now why is it happening so? So you can see here after the abstraction, here this OH will be present, and here we are having is the CN group, and this carbon is having the negative charge now. Why this negative charge is present now on the carbon is your stable form now. That is why this hydrogen has shifted, because the negative carbon with the negative charge, and in the adjacent you have is this C triple bond N group. That is your electron withdrawing group, which will stabilize the negative charge of this particular carbon atom. That is why the hydrogen from the carbon has shifted to the oxygen. Okay, now in the reaction medium we have is the more amount of the furan rings, in which the aldehyde group it has been substituted, right? So this carbon, the negative charge is gonna shift, will be attacking over this carbonyl center, and this electron density will be shifted. So we are going to get here is this form now. So here C with the OH and the CN group is present, which has attacked over the another carbon center, which was having the, which will be having now the O negative, and here we have the hydrogen, and the furan ring is present like this, right? Like this the species will be getting being formed. So now what is going to happen next? So the substrate that we have got now is your this one C with the OH and the CN, which has attacked over this carbon, which is having the O negative, and here is the hydrogen, and the furan ring is present like this. So now what is going to happen? Now CN is your good living group, so this O negative will be abstracting the proton from here. So we are gonna get here is this species now, carbon with the O negative and the CN, carbon with the OH group is present, and here will be your hydrogen center, and this furan ring is present like this, right? Now what is going to happen? This oxygen's electron density will move, and this CN can leave from here. This is why the transfer of the proton has occurred, so that CN can leave from the medium. Also you can see that because of the electron withdrawing group, the negative charge at this oxygen center will be more stabilized. So that's why also you can say this proton transfer it has occurred. So ultimately what we are getting here is, so we are gonna get now is this furan ring, okay, with the carbon. Here the double bond will be formed. This carbon center is having the OH group, and here the hydrogen, which is attached with the another furan ring, right? This species is formed. Now after the attack of the KCN, they have the second step. After the second step you are getting is your this product, this species is getting being formed. Now they have done is the oxidation of this species, and then the KOH species is passed. Okay, so now here we are having is this species getting being formed, which was my C double bond O with the COH. Here the hydrogen is present, and the furan ring is present. Now they are doing its oxidation. Now by the oxidation, what is going to happen? This alcohol group will be converted to your ketones. So we are getting is diketo species getting being formed, right? Here COO, and here will be your this furan ring is there, right? Now this is the step after the oxidation has been done. Now this substrate that has been formed now is treated with the KOH. So here we have now is this diketo, and here will be the furan ring. So this is treated now with the KOH. So now you can see this substrate is ready for the another named reaction, which is your diketo species is with the basic medium is given. That means the reaction will be your benzil benzilic acid rearrangement. Benzil benzilic acid rearrangement. So in that what we basically have, at the same carbon center an acid group is present and the alcohol group is present. So what is going to happen? Let us through the mechanism have a look. So OH will be coming and attacking over one of the centers, because both the centers are now similar only. There is no difference in the electrophilicity, so either of them can be attacked. This electron density will be shifted. We are gonna get here is this one, here the carbonyl species, here the carbon with the O negative, at which the attack of the OH has occurred, and the now this furan ring will be present like this, right? Next step will be this O negative will be electron density will be shifting, and this furan ring is gonna shift to this center, and this electron density is gonna shift like this. So we are going to get here is this species now. At the same carbon center your two furan rings will be present, okay? And here the two furan rings are present, and at the this position we will be having is the OH group. After the protonation I am writing this, and here will be your COOH group, right? So this will be attacked from the second position. We are to draw this. So here the oxygen like this. So this is the species you are getting. So at the same carbon center now we have is the acid group and the alcohol with the two furan rings, that was the substituents present over here, and this is gonna be the final product for your benzilic acid rearrangement. So this is how you can see that the heterocyclic reactions they can be combined with your name reactions. So firstly here there was the benzoin condensation, and here is the benzilic acid rearrangement, and in the previous case there was when no alpha H present, so Cannizzaro reaction possibility was there. So this is how the both of these can be combined, your name reactions and your heterocyclic chemistry, right? Now let us move on to our next question that we have is your this one. So here this question is very good. So a lot of the things we are gonna learn in this. So in the first step is they have taken is the naphthalene. They have treated is with the V2O5 in the heating condition, giving you the formation of the product A, which is further treated with the an ammonia, giving the product B. Then KOH with the Br2C, and the whole process is gonna proceed. So large number of the steps are there. So one by one we are gonna solve all of this. So in the first step they had was naphthalene, this species is there, and they treated it with the V2O5 and the heating of the system. So this is basically gonna do the oxidation of the ring. So we are gonna get here is this species. So one of the ring is oxidized, getting being converted to the acid. So this is basically the role of your V2O5. Now at the adjacent position we are having is the two carboxylic acids. So water is gonna leave from here, right? And we are gonna get here is the formation of the anhydride at this position, right? So we are gonna get here is C double bond O, and here will be the oxygen with the C double bond O, and here this bond will be present, right? So this anhydride is formed. So this is basically your product A that is formed, okay? Now in the next step they treated this with the ammonia, okay, giving you the product B. Now the treatment of this with the ammonia we are gonna do. So both these carbon centers are having the same electrophilicity now, so either of them can be attacked. So this electron density will be shifted, will be coming back, and this group is gonna cleave, because this is will be your good living group having the O negative with the C double bond O, which is your further attached with the benzene ring. So this is your stable bond, so it can easily cleave. So we are getting here is the formation of this thing. Here at this position, C double bond O and the ammonia attack, that is gonna give the amide, right? And here will be the formation of the C double bond O and the OH, right? So this is gonna be your product number B. Okay. Now in the next step, they have passed this the this was a bean, and then they have treated it with the KOH and the Br2. Okay, now the species that we got here was the C double bond O and the NH2, and at this position we had was the acid. Now this is treated with the KOH with the Br2. Now this reaction conditions are for your Hoffman bromamide reaction, Hoffman bromamide reaction. In that, what happens is your amide is getting being converted to the amines, amide to the amines, it gets convert, right? So this co is gonna leave from here just, and we are getting is the amine group getting being formed. Okay, so here nh2 will be there and the cooh is there. So this is gonna be your product number C. Okay, now this C is now treated with the NaNO2 with the HCl. Okay, so now this species, which was my, here the NH2 and here we had was the COOH species. Now they treated it with the NaNO2 with the HCl. So now this is the conditions for the reaction, which is known as your diazotization. Diazotization, azotization. So in this, what happens is your amine, that is your NH2 group, it gets converted to the N2 positive, right? So what is going to happen now? We are gonna get is N2 positive with the COOH group. So this is your basically your product number D, I guess. So this is the product number D that we have got. Okay, now this D, they treated it with the heating conditions they have provided. Okay, so now after the heating of this has been done, what is going to happen is this, let me just expand this. I'm gonna show you this process. So here you had was the COOH group. So now this electron density will be shifting, and this electron density will be shifted to this side, and this nitrogen group is gonna leave from the medium. So basically what we are having is the formation of the benzyne at this position, along with the release of the gases, that is your CO2 and the N2 gas, which are the driving forces for this reaction, because the entropy of the reaction will be increased after the loss of this. So this is basically your product number E that we have got, where your benzyne is getting being formed, right? Now this E is then treated with, so E we are having is this benzyne formed. Now this benzyne is treated with the this furan ring, and the heating condition of it has been provided. Okay, so this benzyne, and we had was this oxygen, and this electron density is present, and the heating condition of it. So you can see here, the here you have was your dienophile, dienophile, this benzyne is there, and this species that is your furan is having your diene, because it is least aromatic, so the diene character is very high in this, so this pi electron density can go for the attack. So in the heating condition, the reaction will be your Diels Elder reaction, which is your 4 plus 2 cycloaddition reaction. So we are gonna get here is the formation of the species. So what is going to happen here is this furan you are having, Okay, and the diene is there, and we have here is your dienophile. So this electron density will be shifted like this, and we are gonna get is the formation of this thing. Here your benzyne will be present, and here the oxygen, and here the double bond will be formed. So basically we are getting is this species now. Okay, so this is the product number F, right? Now further, this F has been treated with the H2 with the palladium and the carbon. Okay, so now this F that has been formed, it is treated with the H2 with the palladium and the carbon. This particular reagent is used to cause the hydrogenolysis. Hydrogenolysis. So we are gonna get here is this carbon and the heteroatom bond will be cleaving. This is known as your hydrogenolysis. So we are gonna get here is this alkene, and here will be the OH group getting being formed, and this benzene ring is remaining the intact. Now this is basically your product number G. Right, now next step is they have treated is this with the hydrolysis of this has been done, that the H positive and the water condition is given. So we got here was this species. Now here we were having, and here the OH is present. So now what is going to happen is they have given is the H3O positive, which is nothing but the H2O in the presence of the acid is given. That acid is going to act as your Lewis acid. So what is going to happen, the lone pairs present on this will be obstructing this H positive. This is gonna be protonated. Okay, so this ring is present, and here the double bond, and here your OH2 with the positive sign it is gonna come. So this H positive, the water that is present in the reaction medium, that is gonna abstract the H positive. This electron density will be shifted. This is gonna be shifted, and the water is gonna leave from here. So we are getting is again the formation of your naphthalene only. So this electron density is present, here the bond is formed, and this bond is getting being formed. This is your product number H that you have got. Okay, so this is the product H. Now this H, that is again the naphthalene that we have got, is now treated in the two of the conditions with the H2SO4 at a temperature of one is at the 80 degrees centigrade, and the other H2SO4 is treated with the 160 degrees centigrade. So the temperature differences are there, which means the thermodynamic and your kinetic products will be there, and H2SO4 is gonna cause the sulfonation over here. The sulfonation, which means that the substituent will be your SO3H. So at the low temperature, basically we have is the kinetic product, kinetic product, and here this species will be formed. This rings I'm drawing like this only. So here at this position your SO3H will be present, and at the high temperature we are getting is the thermodynamic product, and in that case the substitution on the naphthalene will be at this position. This is at this position. So why is it so that at the different temperature conditions we are getting is the different products? So you can see here the two products that we have obtained at the lower condition, that is your SO3H is present, and here is your hydrogen present, right? So this SO3H is basically your bulky species. So this spherical shape it is gonna be there, and this hydrogen is also there. So the repulsion is present between them, right? So that is why it is your kinetic product, and the thermodynamic means the one that is maximum stable one. So in that case there will be no such repulsion is observed. So that is why here your SO3H is present, and here your hydrogen group is there. So in between them no repulsion is there. Here there is hindrance. Hindrance is there just Because of that, because of the electrostatic interaction kind of the species, this kinetic species got formed. But the maximum stable species we want is the thermodynamic, that is even high temperature conditions we have given, even if the activation energy is high, this species will be formed. So this is your thermodynamic, in which there is no hindrance present between them, right? Along with that, we can see that here, after the attack of the electrophile that has occurred, it is occurring at first at this position, right? Now here will be the presence of the electron density, rest bonds were remaining the same, and the this intermediate is formed. Here in this case we are having is, if the substitution is occurring at this position, here the positive charge will be formed at this position, right? Keeping the benzene ring intact in both the cases, we can see that in the kinetic species that is formed, here will be the, it will be resonance stabilized, right? Whereas the thermodynamic, this is not gonna be resonance stabilized. If I keep this benzene ring to be the intact, this resonance is not present, so which means that the resonance is formed, so the kinetic product is formed through this pathway. We want the kinetic, that means the stability we wanted initially, right? But here, after the steric hindrance, if we look, so the thermodynamic product is your this one. So main thing is you have to remember where the substitution is gonna occur at the thermodynamic and the kinetic conditions. Okay, so this question seemed to be very difficult to us because large number of these steps were there, but proceeding step by step for each of the reagent that is mentioned over the arrows, we are easily able to solve such type of the equations. Okay, organic actually seems to be difficult, but if we proceed step by step, then we are easily able to solve the big questions like this. So you can see how different products were there, how many different products were there, 10 to 11 products we found, what we were easily able to solve it if we proceeded one by one. The role of each of the reagent we knew, and for that, because of that, we were able to solve it, right? So now let us move on to our next question that we have is your this one. Okay, so here you have is furan treated with the bromine and methanol is there. Now a solvent is passed, giving you the product number A, and then the hydrolysis of it has been done. Okay, so what is going to happen in this now? So here is your furan species. First is Br with the Br group is there. So first is the electrophilic attack. This electron density will be shifted, having the Br, and one of the another Br is gonna leave from here. So we are gonna get here is this species. Here will be the positive charge, and one of the Br has been substituted. Right now, what is going to happen next? This oxygen electron density can move, and this positive charge can be neutralized. Right, giving us this species. Right. So here now a positive charge is at this oxygen center, and in the Br is there. Now in the reaction medium they have given is the methanol that is present. So now this methanol is gonna come and attack at this position, and this positive charge over here will be neutralized, right? Giving us this species now. So here again, here we have is OMe, and here this electron density will be shifted, and this Br group is gonna be there. Okay, now further what is going to happen next? This O negative, and here we have got this species. Now here Br is there and your OMe is there. Now again what can happen? Oxygen can donate the electron density, and this Br is can leave from the medium, giving us the formation of this species. Here at this position your OMe was substituted, OMe, and here now a positive charge is coming at this position. Now again in the medium we have is the methanol that is present. So this O, oxygen's electron density, will be again coming for the attack at this position. Just a second. So we got here was this oxygen. Here the positive charge will be at oxygen, and this OMe will be present, and this electron density was present. So now OMe H that is present, methanol, is gonna come for the attack, neutralizing the charge. So at this position, we have is the OMe group substituted at both of these sites. So this OMe group is present. So whenever you have is Br2 with the methanol, in that case your second and the fifth carbon centers are substituted with the OMe groups. Okay, so this is your product number basically A. Now they have done is its hydrolysis. So now they have done OMe, that is your this allylic species, and this OMe is present. Now they have done is the hydrolysis of this. So after the hydrolysis, the final product that we are gonna get here is this species. Here your keto carbonyl species will be present like this. Carbonyl species will be there, and here your methyl groups will be there. So after the hydrolysis, you are gonna get is your this as your final product. Okay, so main thing is whenever you are having is the bromine, in that case you are gonna do is the substitution at the of the with the OMe at the second and the fifth position. Okay, now this was all about the reactions of your furan.